Okay, so moving on to number 5, section 5, we're looking at dilations, continuing with this transformation stuff. So we're looking at section 5, which is dealing with dilations, which we've dealt with before when we talked about our unit about scaling. Okay, so when we were scaling stuff, we were dealing with our dilation. So what a dilation is, it's basically a transformation that has a pre-image and an image that are similar, but they're not there's no isometry, so they're not congruent, okay, but they are similar. Dilation is basically making an object larger or smaller by a scale. So if I take, if I have a model car of a Corvette that is, 1/64th scale, that is 1/64th scale compared to a normal Corvette size. So that's my car is a dilation, which would be a reduction of the original. Okay, so enlargement and reduction are two. So if the scale factor is larger than 1, that means it's an enlargement. That means that the object was getting bigger. Okay, if the object's getting smaller, we call that a reduction, and the number is going to be a fraction that's less than 1. So like 1/4, 1/64th would be a reduction. Okay, it goes from a large object down to something that's 1/64th the size or 1/2 the size, whatever it is. These are used very often because you've got to do a scale model of something before you want to build something larger. So, you do a scale model of a building so you can see visually what it would look like before you actually build the building and then see what it looks like. So these dilations and these scales are fairly important. Okay, so this would be an enlargement. So you see the red is our image and the blue is the red is our pre-image and the blue is our image. And you see with an enlargement it gets bigger. So the object has just been, I think it's about doubled, maybe even a little bit more in size. And so it's just gotten larger. And it's gone from red to blue. And you can tell that the blue is the image because it's all prime. So it's A prime, B prime, C prime, and D prime, meaning that it's the image. So this has been made larger. So that's an enlargement. Okay. This would be a reduction, so this is making it smaller. So as you see, the red one, which is our pre-image, ABCD, is larger than our final image, okay, which is A prime, B prime, C prime, and D prime, which has gone down to blue, which as you see, it's gotten smaller. So since it's a reduction, that means that the scale is going to be a number less than 1, but more than 0. So you shouldn't have any negatives when you do these problems. Okay, so take a second. I want you to find the scale. The red and blue still matches what it was previously. So find the scale of this and see what you get. Okay, so when you do these scales, what you want to do is you want to make sure you've reduced the fraction all the way, because you don't want to say, a 6/3 when you can just say 1/2 or 2/1 or 2. Okay, basically it's been doubled. So if we want to find the scale of this one, what we do is that we take the image and we divide it by the pre-image. Okay, so it's always going to be image over pre-image. Okay, so you have your final divided by what it was originally. So the final one of this one is our blue. So if you remember previously, blue has been our image, red's been our pre-image. So we take the we take the length of each side, 10, and we divide it by 4. 10 divided by 4 is 5/2. So that means that our scale in this case, or of our dilation, would end up being 5/2. Okay. All right. Take a second, find the scale of this one. Okay. So with this one, we see that we have a reduction. We go from the red to the blue. Again, red is our pre-image, blue is our image. So we've gone from red to blue, which means that we're going to be shrinking it. So that means we're going to have our image on top, 3, and our pre-image on bottom, 12, which reduces down to 1/4. So because it's a reduction, it's getting smaller. Okay, so because it's getting smaller, we have to make sure that our scale fits that, which would be less than 1/4. Okay. All right, so now we might have something that looks like this, and we might go, okay, is this a dilation? If so, what is the scale? So you might just be given an image and going, okay, what is the scale of this? And if it is a dilation, what is the scale? Okay, so looking at this, first off, is this going to be a reduction or is it an enlargement? This would end up being a reduction because, again, red is the original and blue is the final. is the image. So that means we have a reduction, which means our number should be less than 1. So now what we want to do is we want to see is it a dilation, and then what is the scale. So if it was a dilation, that means every single side has to agree with every single side needs to agree with the scale that we've had. Okay. And so what you could do is you just take a division of each one. So if we go new over the old, we'd go 7 over 12. Okay. So we'd go 7 over 12 and see, okay, that's what we get as our decimal. Then you'd go 5 over 60 over 7. And then you go 4 over 48 over 7, and then 6 over 72 over 7, and then 3 over 36 over 7. And you'd want to see if it has the same scale. So take a second, identify if it is a dilation, and if it is, then what is the scale of this image? Okay, all right. So again, it should be less than 1. I believe it's 7/12. 7/12 would be your scale, and it is. Okay, so here's your homework for this one. Make sure you work on it. Make sure you have any questions and all that stuff. All right.